I hope everyone is having a good time so far. So today I'm going to talk about guardrails for agentic AI, more in the context of governing auto-generated SQL and Spark jobs before you do anything in the production environment. So just a brief disclaimer before I proceed that some of these opinions and ideas which I expressed are solely my own and are not reflective of my position or policies of my employer, etc. So before I start, the whole idea is about the generative AI nature of large language models. So giving you a quick insight here, nowadays you have very popular large language models. You can consider some of these are very generic large language models, which are proficient in a lot of things. There are also SQL or programming language based large language models, which are trained specifically on the schematics of how a SQL language is based upon. So you can think about this particular where I'm asking a chat assistant what were total sales by region last quarter, and it gives me back a response which is select region, and it looks semantically and formatically very clear and looks perfect to me, which I can then as a stakeholder, the product manager, use this to actually associate it with one of the tools. So the tool could be a Postgres server, it could be uh, your Spark engine, and you can associate it and run it and get the response out. You can think very similar to what some of these different engines right now are doing. One comparable example could be the database Genie perspective, where you write ask a question and you get back a response from database Genie. The key question here comes is how appropriate is this SQL query in the context of the question which is asked, and is it performant? Is it efficient? How much cost is it taking? How frequently can one rely upon this? So this is where we can think about one particular sequence of events which happens, where you can see in this slide that the user asks a data question. It could be an LLM or an agent planner, and it has all the schema and context because that's where the prompt or the context engineering part of it comes here. So it has access to the tables, columns, and whatever indexes and specific examples and documents, which it could have it in context. And then it generates a SQL query for you. And not only does the SQL query generate it, but you also need some contextual data around it. So it runs it in the Postgres or the Spark engine of your choice, and the result is then returned here. Now, one good question is what goes wrong in this direct part? So one of the cause could be an inefficient query, it could be the right query, but maybe it's not perfect enough to execute in that particular engine of choice. The second is the access challenges, whether you're allowed to run a particular query for a particular column. So, does the access capability allow you to let your conditions or access policies be transferred through the agent to the end engine? And the third could be the unintended inference, which is kind of deriving disallowed sensitive outputs which you're not allowed to. One example could be, let's say you're given access to two tables, and from a general perspective to query it makes sense. But how about agentic and LLM interfaces give you those inference capability to join certain data sets and garner those inferences which are not supposed to be your role specific information. So how do you guard against that? And similarly, you have other challenges too, like the timeliness gaps in terms of what could be the wrong business answer to the question. And the fifth is the intent mismatch. So the SQL could be valid, but is the result and the sequel answer the question which is put forward by a data engineer, analyst, or a product manager. So the second context here is which we talked about a bit, that is the data model documentation, is where the first guardrail happens. So you can think about the data model as to whether you have primary foreign keys, you have fact and dimension joins and how to connect them. Similarly, indexes, schema comments, and example values goes a long way because that also interprets in terms of the statistical nature of how some of these large language models perform with example queries to help you. So this definitely takes it to another level where the LLM with the schema and business context generates SQL but with fewer blind spots here. And this could then be executed through a query engine. Now, the third part comes here is the contextual environment around which the execution happens. So instead of the LLM inventing or running joins and metrics directly, a semantic layer of the tool helps here even before the execution happens. So if you think about this particular sequence where the user asks a business question, the agent or the LLM interprets the intent, and even before the engine executes it, a semantic layer, very similar to you can think about the metric style, which kind of is exposed on Databricks, has the wrapper because it gives you another engine which is meant around a very specific guardrail. So you cannot go beyond the guardrail. The challenge here becomes the open source nature of it. But eventually, I think Databricks recently, I think they open source the semantic layer in which it can be implemented in other sources. So I think this brings another opportunity for this pipeline to be integrated in very custom pipelines where your flow is constrained within the wrapping layer. So this could have, we can think about what are the current rules which the database engine metrics has, but this can be extended to customize it against your rules and more specific constraints to be precise. The next part to it is one of the relations is when you run a SQL query, one can validate the context behind the SQL results. So when you run a SQL query, you get the output here. How do we validate the graphic nature of it? Because graphs really help you in terms of joining the relation, finding out the more informations which are correlated. So you get a secondary nature to how the joins happen. So this gives you another layer at which this check could happen. One of the important parts when, let's say, creating a prompt is the benchmarking part of it. So one needs an evaluation set of like a bank question set with the relevant SQL examples, both good and bad, because they help to train the knowledge of the large language model. And in this context, it also helps not only to run against one large language model, but a candidate of large language models to be run in parallel so that to find the right prompt, the right large language model for the right context in terms of different engines which you're running against. And the score outputs the correctness, the policy cost, and the different latency which is expected. One of the other aspects when you're fine tuning your prompt is not to do it based on some changes, but to do it based on the metrics. This is where I think the optimizer in the DSPY uh, framework helps in, because what it does is it changes your prompt based on the usage of a particular tool, and this tool in our case could be the Postgres database or a Spark engine, and it runs variances of your prompt against the tool of choice, and it compares the result with your expected. So through a metric enabled automation, you can definitely do it on a fine tuned basis, on a reiterative basis to compare it. So here you have the evaluation set along with your context tools to help you build this fine tuned prompt. One of the perspectives, if you think about, when you run from a SQL query and you want to validate it, we have to see the signals in benchmarks, because when you think about the sequence of tasks which happen in the flow from executing the large language model to generating the query to validating it against an explain class. So all of these add to the latency and also to the measurement phase. This is where adding the traces enable us to make it more efficient, because we can consider the different parts where we can improve the process in an incremental manner. And at the same time, we talked about the evaluation, the DSP prompt optimization. We also need a human in the loop, because we have to validate how this particular SQL is adding value in terms of the question which has been asked. This is where the business domain, the data engineers, and analysts can definitely help by giving feedback on these responses on an iterative basis for testing. Now, in the previous section, we saw a very simple sequence where the user query went through a large language model, and then we generated a model, a SQL from that particular model. Now, one of the other aspects which we can do here is to improve it through a parallelization. That is, we run the query through different large language models by passing it through a central orchestrator agent, and the SQL which is outputted can be then compared in the final analysis, so that you have a comparative average out but better performing SQL which is more contextual in the context of the question which has been asked. So some of the side effects of this is the higher model plus the engine cost, because you're choosing different models to experiment here, because you are doing it in a parallelized manner, and the end-to-end latency also increases because the large language model at the end has to process all of this together, and eventually your audit surface is increasing because you have now different tools which are being orchestrated in a linear fashion. With this in consideration, now the next flow which we talked about is the execution of that tool. So you see the natural language intent here with the agentic planner, and the agent planner now executes the SQL query on the Spark artifact, and this could then run in the distributed environment with the result back to the user. Some of the challenges here, as we talked about, is the correctness. So it could result in incorrect results to propagate, and the policy effect, which is how do we put the governance layer to act before executing the SQL on the uh, final data set. And eventually, you have the cost aspect because of the performance. We do not, in exactness, know whether the SQL which has been generated is a perfect SQL query to be run in a performance environment. So these are some of the failure modes which one has to govern before the runtime execution. That is, check for the hallucinated relationships, unbounded execution, that is selecting star over a very huge table. So how do you factor that in? Silent Cartesian products, which is you're simply doing a cross join and exploding the row counts and shuffling in a very highly distributed environment like Spark. Fourth is policy bypassing, that is sensitive columns are being referenced by your centralized SQL engine, and also like Spark anti-patterns, like doing a collect or writing a UDF, etc. So if you think about all these different factors or the patterns, one constraint cannot help us here. We have to use different methodologies to tackle all of these issues. So, and first, you can think about hallucinated relationship. How do we factor that in? So, one is that we can use a analyst or a the optimizer part to verify whether the keys are matching or the right set of schema is verified. Unbounded execution by checking for these factors. This could also be done with something like an analyzer like Apache Calcite, where you're running through it and you're measuring the effect of it, whether the predicates are used, whether there is a column filtering. So all of these can be done through different levels of guardrails which can be established. But these guardrails are not established by the large language model, but these are more established by the predictive determined nature of the optimizer and different analyzing SQL or Spark engines. One example, to be more specific, is Apache Calcite, where you can pass the SQL query through it, verify the nature of it in terms of what it executes against. One of the challenges which I see is it's not about the right or wrong path to it. It's more about how do we evolve the system going ahead. So you can think about a business user asking a particular question. The There are two ways to think about whether the question was asked more as a learning experience or more from a search for an answer to it. How do we choose the best iterative manner to help different use cases when it comes to this? So this is where a an assistant can restate what is the intent plus the assumptions it is taking so that it can be in a reiterative manner confirmed by the business or another analyst as to what it is actually trying to do. So with this confirmation of scope, that's where the context engineering part comes in, because one of the factors which results in a huge hallucination is a single static prompt which you're feeding out to the large language model. Rather than it, there needs to be a context engineered index from which different contexts can be searched based on the flow and the task level at which the operation is performing at. So you can think about having different modes of operation, like a quick mode based on needing a quick example, quick solution or an explanation to it, while an explainable mode where you need more detailed performance graded solution. So you're not only using tools like just running it across a Spark engine, but you're also getting the plan of it, running and explain on it, and different other contexts by getting more data, which is more in the descriptive mode. So the business correlation really helps you to find the smooth path ahead in an incremental journey to do this. One of the important factors is to establish governance. And these are very well established in different platforms, which are both open source and also some of which are closed proprietary. But the governance layer is very important, and this is where checking if one has access to the particular data set is really important because these are non negotiable rules and should be blocked immediately, even before executing them on an engine of choice. And all of this are eventually logged, but this is where we can save some of the efficiency and the cost in the process by keeping this guardrail check in the very starting of this process. So, three governance patterns, um, and you can start as we have seen some of the patterns as AI with AI, where you get a response, but you can pass it to another large language model and get a uh, judgment on it based on LLM judge. But it's fast, good for semantic hints, but it's still it's an audit alone factor and still is sensitive to your prompts and could be a failure mechanism. The second is a human in the loop, where strong accountability and domain judgment is there, but again, it acts as a bottleneck because of the slow path. The third choice is the hybrid, where the deterministic controls first, with different checks which are available, and the LLMs assist with humans only on the low confidence or high impact paths. And it brings the best balance if you see speed with the measurable safety. But it also needs different policy ownership, telemetry, and all the setup which is needed. This is one of the pre-flight architectures which should happen even before your execution engine starts, where you have the intent validator. This is where you compare the request, plan it using Apache Calcite or the engine from Spark, and determine the input artifacts and the target outputs by checking the schema, etc. The second is the metadata resolver. This also comes to the lineage part, the ownership, and all the different tables and columns. Some of these can also be used through the optimizer part. The third is the policy and the access gate, along with the cost performance. This can be done through the explain, getting the stats, partitions, and all of this, if you see, are helping you resolve your queries. And this information really helps your large language model and agents to derive better sequels and in a reiterative manner.
What was that?
Now,
Sorry, man. I don't know what happened there, but go ahead, keep going. I had to kick somebody off. Somebody went rogue on me.
no worries.
Sorry. We'll
Okay.
keep rocking.
So now, if you think about from a technical architecture, how do we build this? So here, if you think about the user query, you have an LLM agent. Now the SQL is generated from the system. This SQL is then passed by Apache Calcite, where you pass the SQL and you generate the AST syntax plus the dialect, and we resolve the catalog and the schema map, then the entity graphs, tables, columns, and the joins. This is more in the specific of the SQL language, but it can also be leveraged on the Spark engine by using the explain for Postgres and explain for Spark. These generate different plan signals, and these could act as the pre-flight guardrail service, where we are checking for the fast access verification, also doing the static SQL risk checks, and the planning, which is the most important part in terms of generating a performant query. And this is how the flow looks like, with parsing the AST to resolving the catalog, analyzing lineage. And this not only has to be done on the Apache Calcite or the optimizer level, but also as a policy or score, because one wrapper engine could also be set up which checks for these values and maps it as to how many bytes it is parsing, whether it should block it, because it could have different guardrails based on a dev sandbox environment versus your production as to how much information should get passed and what. So this is one way as to how you can use bounded LLM judges, but they should not be acting as the root of your trust. They should be more policy oriented, as we talked about here, through the execution of the policy engine. Now, another approval workflow, if you think about the confidence versus the impact, is where do you have the auto approval process at different environments and based on the confidence. You block or rewrite it while in a warning play in the sandbox environment because it all depends upon your use case, whether it's an exploratory environment where you want the learning for your stakeholders, or you are in the very production oriented environment where you want a very strict approval process based on your bottlenecks and the fastness in terms of what you want to approach. One of the things which usually gets talked about is how do you compare cost versus speed? Because if you run across multiple models, if you run a single query in a Spark engine and it fails, you have to rewrite it or retry it again. There's a cost to Spark because it runs on a very parallelized engine. So one advantage or one pattern I've seen here is you can do the static checks, but run it against a SQLite maybe. So you are checking, you're verifying your SQL for syntax and the correctness because there are two parts to SQL. One is whether you are running the right SQL, which is performant, and whether the value which is received as response matches the expectation. So a lot of iteration happens at this stage. So I think a sample data which is put in SQLite or Postgres, which can be run against, reduces your cost a lot. And once this core idea is verified, this can be run on a Spark dry run and then with a full Spark run. So this gives you the confidence gate before the expensive run, but at the same time, you reduce the cost and gain more confidence in the sandbox environment. And this is
Just
how,
a quick time check, dude. Sorry. And we've got a ton of questions. So if you wanted to answer Q&A, it would probably be good to get that started soon.
yes, I think we are good to do that. Yeah, we can take the question.
All right, cool. Well, let me jump in on the questions. There are a few in here in the Q&A section. Just as a reminder to folks, if you want to get your question answered, throw it in the Q&A section. And if you want to have a specific question be asked by me, upvote the other questions. We've got one coming in here that is a single query generated of all relevant queries set generated? For example, when we get total sales of first quarter, then may need to total sales for Jan, Feb, March also. Does that make sense to you?
So is a single query generated or all relevant queries set generated? So it again depends on the context in which you are putting the question. And this is where also some of the React patterns where you are saying a reason about it and then answer it also validates. And some of these large language models could be resulting in the very first where you're just giving a single query and not focusing on the Jan, Feb, and March part. But this could also be explained by giving it more reasoning capabilities by using a better large language model or a bigger one, but at the same time giving it more context around to think around different areas because it again depends on what the stakeholder is requesting to. So I think some iteration here really helps you to find the right choice.
All right. Next one up. I'm just going to start rapid firing them for you because there's a few awesome questions in here. Did you experiment with things like interview phase where the agent has access to metadata tools and goes back and forth with the business user to validate the request?
That's a good question. So uh, it's again when I talked about the sandbox environment. So it has access to the metadata, and at the same point, it can give you those flexible answers of choice. Uh, and Demetrius, can you also put back the question? Sorry, where did
Oh, shoot. I dropped it as answered, but it was
okay.
if you experiment with the interview phase where you go back and forth, it has access to the metadata, and then you go back and forth with the user to validate the query.
Yes. So I think this is also based on the iterative phase where you show the answer and you get some more feedback, because you have to think about how we human beings have performed in the past by interacting with analysts in a true, to and fro manner. And this is where we can start in a simple phase, because this gives them the confidence that they are comfortable with this process already, and then start improving upon it.
Cool. So, what if the schema and the values changes? How do you resolve that?
So this is one of the interesting factors. That is, what if if the schema changes? This is where you can think about the dynamic layer, because you have feature engineering and you can fetch these schemas dynamically on the run. So you always have a schema fetching from, let's say, a Spark engine. You can fetch it on the run on the context engineering part. So there are two parts to it. One is the static prompt, while you can do a context engineered SPA. So let's say when you want to validate your schema, you don't feed it the entire prompt, but you know that in this context, you just need the schema. So at that time, you fetch the schema through a tool and feed it in the context to the large.
Last one for you, man, and then we're gonna get rocking and rolling to the next talk. Lynn is asking, how do you avoid creating another data silo with AI platforms?
So if you think about this, mm, we are not trying to create here a data environment, but more of a platform to practice your data exploration as a starting phase. So your data is still there in your data lake, which is the source of the answers or the solutions which the large language model will execute upon. But this is more kind of a phase where you're empowering your product managers or your leaders to answer these questions through self exploration as a very first step, and then incrementally take it to, let's say, empowering them to create new data sets from this through different other varieties of transformational queries as the next step.
All right, man. Well, this has been awesome. I see that folks did not upvote my question, so I'm not going to hold a grudge on you all, but that's uh that's not what I was hoping for. I wanted to ask my own question, but I also want to ask your question. Thank you all for joining this one and asking the questions. Satij, I'm going to kick you off now. This was great. We got the